Welcome to The Explainer. Today we are diving headfirst into the very fabric of existence itself, and we're being guided by the brilliant insights of world-renowned physicist Dr. Michio Kaku. We're going to explore some of humanity's absolute most profound and honestly baffling questions. We're talking everything from the origins of the universe and the actual mathematical probability of alien life, right through to the fast-approaching quantum computing revolution, and even the biological quest for human immortality. It's going to be a wild ride.
Okay, let's dive right into this. Dr. Kaku drops an absolute bombshell right out of the gate with this thought. He essentially argues that the three-dimensional world we interact with every single day, it's really just a tiny itsy-bitsy fragment of true reality. Think about it. We can't see cosmic rays. We can't see ultraviolet light. We are completely blind to the full spectrum of existence. So basically, the world as you and I perceive it is a highly filtered illusion. It's a partial fiction that's just programmed into our brains. Which begs the question, if our reality is an illusion, what is actually going on out there?
Section 1, the theory of everything. So for the last 71 years, Michio Kaku has been trying to finish Albert Einstein's ultimate dream, and that is finding a single 1-inch equation that explains the entire universe. Kaku's life's work to find that equation is totally wrapped up in string theory. You know, the traditional way we've been taught to look at physics is that at the base level, the universe is just made up of tiny point-like dots, right? Electrons, protons, neutrons. But string theory completely flips this on its head. It proposes that these fundamental particles are actually just different vibrations of a single one-dimensional string. If the string vibrates one way, well, we call it an electron. If it vibrates another way, we call it a proton. It's literally like different notes being played on a cosmic instrument.
And this brilliantly illustrates the shift in our understanding of matter when we look at these two concepts side by side. On the left, you've got the old standard model. And look, it's great, but it leaves out major, massive mysteries like gravity and dark matter, treating particles as these isolated little dots. But on the right is string theory. This attempts to unite all the fundamental forces by viewing the universe as this magnificent subatomic symphony. The universe isn't just a random collection of billiard balls bouncing around, it's a symphony of vibrating strings playing out the laws of physics. Now, this string-based framework, it completely alters how we understand the universe's origins. If string theory is correct, the Big Bang wasn't just some singular explosion out of nothingness. Instead, Kaku uses this absolutely amazing bubble bath metaphor. Empty space isn't actually empty at all. It is frothing with tiny bubbles constantly popping in and out of existence. And roughly 14 billion years ago, one of those bubbles just didn't pop. It kept expanding. And that bubble, that is our universe. Mathematically speaking, this implies we are likely just one single bubble coexisting in a massive, cosmic bubble bath of parallel universes.
Section 2, our fragment of reality.
It is definitely mind-bending to think about a multiverse. But how does our specific biology actually interact with this massive, vibrating reality? Well, this leads us directly to one of the most popular philosophical questions out there right now. Are we just living in a highly advanced simulation? Seriously, is the universe essentially just a pre-programmed video game running on some alien civilization's hard drive?
Kaku's answer to this is a fairly firm, probably no. And the reason lies in the very nature of quantum mechanics itself. You see, a simulation requires a script. It needs a definitive set of pre-written outcomes to function. But the universe doesn't operate on definitive scripts. It operates on probabilities. The chances of a uranium atom firing or hydrogen fusing to create a star, all of that is based on quantum probabilities, not some rigid digital code. So it's highly unlikely that a simulated script could ever account for the true, wild, probabilistic nature of quantum physics. So, if our reality isn't a computer simulation, it is an evolutionary one. Remember how we said we only see a fragment of the universe? Why is that? Simple. Survival. Kaku uses this really great anecdote. Imagine you're walking along and you hear rustling in the bushes. You might hallucinate that it's a tiger. Now, 9 times out of 10, there is no tiger. But that one time there actually is a tiger, that overactive hallucination just saved your life. Evolution didn't program us to see infrared or ultraviolet light or this beautiful cosmic string symphony. It programmed us to see whatever keeps us alive long enough to reproduce. We're blind to the wider universe simply because seeing it wasn't necessary for our survival.
Section 3. Are we truly alone?
Okay, so having established that our human senses are, quite frankly, pretty limited. What happens when we look out into the cosmos with our advanced scientific instruments? Especially given the recent flood of declassified UFO sightings, we have to ask, are we truly alone out there? To even begin to understand this, we have to grasp the sheer crushing scale of space. 70,000. That is the number of years it would take our most powerful Saturn V rocket just to reach the nearest star system, Alpha Centauri. It's a hop, skip, and a jump in cosmic terms, sure, but it is an absolute eternity for humanity. Because of this massive distance, any civilization capable of physically visiting Earth wouldn't just be a little smarter than us. They would have to be hundreds, maybe thousands of years more advanced, possessing the kind of tech that can actually warp space itself to bypass the speed of light. When it comes to all those UFO sightings that have been dominating the news lately, Kaku breaks down the scientific framework for us. He says there are 3 distinct kinds of close encounters. Step 1, you see something in the sky. Step 2, you find tangible wreckage, like a piece of an engine or a hull. Step 3, you're actually shaking hands with the beings. Now, despite all the declassified videos and dancing blurry lights on our screens, humanity is strictly stuck at Step 1. As a physicist, Kaku notes that without tangible, verifiable observations, without getting to Step 2, we simply do not have the definitive proof yet. Now, what's really interesting about this slide is Kaku's hypothesis on what these visitors would actually be if they are indeed real. He argues they almost certainly wouldn't be biological creatures. Why? Well, think about the advanced UFO maneuvers we're observing, dropping from 70,000 feet down to the ocean in seconds, zigzagging at hypersonic speeds. These generate G-forces that would literally instantly crush organic bones to dust. Because of that, any true extraterrestrial visitors exploring our planet are highly, highly likely to be autonomous, robotic machine intelligence, not biological aliens.
Section 4. The Quantum Computing Revolution.
Speaking of machine intelligence, let's transition from the vastness of space back down to the atomic level, right here on Earth. For decades now, our entire modern world has run on digital computers. These rely on transistors acting as super simple switches, up or down, 0 or 1. But the revolution of tomorrow, that is the quantum computer. Instead of computing on transistors, it computes directly on atoms. And an atom doesn't just have 2 states, it has an infinite number of states between 0 and 1. This is a complete game changer because it allows a quantum computer to process information in multiple directions all at the exact same time, creating exponential, almost unimaginable processing power. But as you might guess, with infinite power comes some massive real-world stakes. Quantum computers are becoming so ridiculously powerful that intelligence agencies like the CIA are genuinely terrified. Why? Because a fully realized quantum computer could theoretically calculate and break literally any known digital encryption code. This means our global banking systems, Wall Street, and even cryptocurrencies like Bitcoin, which completely rely on complex math equations for security, could become 100% vulnerable overnight. Capitalism as we know it could grind to a screeching halt if our cybersecurity doesn't evolve fast enough to meet this quantum threat. Section 5. The Quest for Immortality. So while we are unlocking the secrets of the atom to build supercomputers, we're simultaneously unlocking the secrets of our own biology. And we're doing it for the ultimate human quest, defeating death itself. Kaku explains that immortality isn't just science fiction anymore. It is a legitimate biological puzzle we are trying to solve. And the key to it all lies in something called telomeres. Think of telomeres like a ticking biological clock at the very end of our chromosomes. Every single time a cell reproduces, this clock gets a little bit shorter. When the telomere gets too short, it frays, the cell stops reproducing, and, well, we age and eventually die. However, scientists have actually discovered an enzyme called telomerase, which can effectively stop this biological clock from ticking down. But, and this is a massive biological catch-22, the secret to living indefinitely is tantalizingly close, but applying it right now is incredibly dangerous. Why is that? Well, because telomerase is the exact same mechanism that cancer cells use to achieve their own twisted version of immortality. Cancer kills us specifically because its cells never stop reproducing. They essentially live forever using this enzyme. So the absolute monumental challenge for modern medicine right now is figuring out how to apply telomerase to extend the human lifespan without simultaneously waking up deadly cancer cells in the process. When you step back and look at all of this, the quantum computers, genetic engineering, theoretical warp drives, artificial intelligence, Kaku stresses that humanity is currently resting on a razor-thin knife's edge. Look at human history decade by decade. The progress we make is staggering. But we are the very first generation in history to actually possess the power to completely destroy ourselves. We are facing existential threats from things like designer germs, nuclear weapons, and potentially rogue AI.
If we tilt the knife one way, we face total annihilation. But if we tilt it the other way, we could unlock a literal utopia with food, luxury, and health for everyone on the planet. And that leaves us with this final, incredibly profound question to think about. As our technology, especially artificial intelligence, becomes exponentially smarter and vastly more capable, Kaku believes we will inevitably have to merge with these machines just to survive and explore the universe. So, will we become superhuman, mastering the tools of physics and biology to explore the cosmic bubble bath? Or will our destructive tendencies wipe us out completely before we ever get the chance? Thank you so much for joining me on The Explainer today.